Click the bell icon to get latest videos from Ekeeda.
Hello friends, till now you have seen that the chapter derivative is going very smoothly because till now we have not started with the substitution method. We have seen in the earlier videos where we have derived the formulas for sin inverse x, cos inverse x and tan inverse x, and also the remaining three inverse trigonometric formulas. But the problem is that in examination we don't have the direct formulas to find derivative of sin inverse x. So here we are going to refer the table that will clearly give us an idea that what type of substitution has to be done for a particular expression. Now, before understanding the expressions that are used in substitution, we should be very thorough with the angles that are required in trigonometry. Yes, I am telling about the half angle formulas. If I say sin 2 theta, cos 2 theta, tan 2 theta, all these formulas should be on the tip of the tongue. So let us try to revise these formulas. If I say we have an expression for sin 2 theta, its formula is 2 sin theta cos theta. Now here I am going to replace these trigonometric ratios by x. Suppose we have the formula sin 2 theta, which is written as 2 sin theta cos theta. Now out of that one trigonometric ratio, I am writing cos theta in square root. So this will be under root of cos square, and that can be written as 1 minus sin square. So the expression can be also written as 2 sin theta into under root of 1 minus sin square theta. So whenever, if you see this expression and I replace sin theta by x, it will look like 2x into under root 1 minus x square. So in this case, you are going to substitute x as sin theta or x as cos theta. Most of the times we are going to use x as sin theta only, because if we use all the two substitution, that might confuse us. So always try to remember only one type of substitution. Now what is the reason behind this substitution? Our basic complex problems become very easier when we use this substitution. So just imagine if you have an expression like 2x under root 1 minus x square, and outside that you have a function sin inverse, and if you put x as sin theta, you can automatically write it as sin 2 theta, and you will get sin inverse of sin 2 theta, where sin inverse and sin will be cancelled and the remaining part will be 2 theta. So instead of differentiating the previous function that was too hectic, and here we are going to differentiate 2 theta, this becomes a very easier process. Now let us see the second expression. Now let us go for the second expression. We have sin 2 theta as 2 tan theta upon 1 plus tan square theta. Now in this formula, just replace tan theta by x. What you can see is 2x upon 1 plus x square. If you have this expression, say 2x upon 1 plus x square, the value that we are going to put as x is definitely tan x. Is definitely tan theta. The third expression that we are having is cos 2 theta. For cos 2 theta, we have three different types of formulas. Out of that, one is the 1 minus 2 sin square theta, out of which one is 1 minus 2 sin square theta. Now here, if I replace x by sin theta, the formula will be 1 minus 2x square. So whenever you have the expressions like 1 minus 2x square, we are going to put x as sin theta. So this will make an easier way to solve the problem. Now let us see the next substitution that we can use during the formula cos 2 theta. The second formula of cos 2 theta is 2 cos square theta minus 1. So again I am replacing cos by x. This will give you 2x square minus 1. So whenever you have this expression like 2x square minus 1, the first thing that we are going to do is put x is equal to cos theta. The last expression of cos 2 theta is 1 minus tan square theta upon 1 plus tan square theta. Again I am going to convert tan theta in terms of x. So the expression that we are getting is 1 minus x square upon 1 plus x square. So whenever in inverse trigonometry you have 1 minus x square upon 1 plus x square, we are going to put x as tan theta, whether it is derivative or the next chapter integration. Now the next expression that you can see is of tan 2 theta. It is given by 2 tan theta upon 1 minus tan square theta. So if I replace this in terms of x, it will be 2x upon 1 minus x square. So there is a slight difference between sin 2 theta and tan 2 theta. If you see for sin 2 theta, we have 2 tan theta upon 1 plus tan square theta. And if you see for tan 2 theta, it is 2 tan theta upon 1 minus tan square theta. So there is a difference of only sign, that is only in the denominator. So if the expression is 2x upon 1 minus x square, the value of x will be tan theta. And if it is 2x upon 1 plus x square, the sum will be converted in terms of sign. Now let us see the next expression. In the next expression, we have sine 3 theta, whose formula is given as 3 sine theta minus 4 sine cube theta. Now just replace sine theta by x. The expression will be 3x minus 4x cube. So whenever you see this expression like 3x minus 4x cube, the first thing that we are going to do is put x is equal to sine theta. Similarly goes with the formula cos 3 theta. It is given by 4 cos cube theta minus 3 cos theta. And its simultaneous expression will be 4x cube minus 3x. So for such expressions also we are going to put x as cos theta. The next expression is 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. So again its expression in terms of x will be 3x minus x cube upon 1 minus 3x square. So in such cases we are going to put x as tan theta. Now as you can see, the remaining 4 are the algebraic expressions. The first expression is under root a square minus x square. Here whenever we have a square minus x square, just put x as a sin theta. Remember friends, this substitution are just used to eliminate the root. Whenever we have more function, the function will become complex and its derivative will be more complex. So to simplify it in a easier manner, these substitutions are used. The next expression that we are having is under root of x square plus a square. Here in this case we are going to put x as a tan theta. If we put a cot theta, then also it's okay, but always try to remember only one formula that will avoid you from confusion. The next formula is under root x square minus a square. Here in this case you are going to put x as a sec theta. And the last expression is consist of 2. It can be under root a minus x or under root a plus x or both. So in such case we are going to put x as cos theta. We are going to put x as a cos theta. I hope friends you have understood this substitution. The first thing that you should do is write down this substitution and try to practice and memorize this as much as possible. If you memorize this completely, you will see that the chapter derivative is way easier. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.